Hello everyone, this is Rudree Pathak from Department of Pharmaceutical Technology, LJ Institute of Pharmacy, Ahmedabad. Welcome to the online MOOC lecture series, an initiative taken by LJ Institute of Pharmacy, part of LJ Group of Institutes, Ahmedabad. In today's session, we are going to talk about a very interesting topic, and that is aerosols, which is included in BPharm Semester 3 Physical Pharmacy curriculum according to new PCI syllabus. So let's begin with our session. Now, let's first understand what do we mean by aerosols and why it is included as a part of BPharm Semester 3 curriculum right now. So, as the name suggests, and as the definition suggests, according to literature, it is a transition between liquid and gaseous state, which is explored in a particular formulation. Under pressurized condition, the formulation is going to behave as a liquid, but once the pressure is released, it is going to behave again as a gaseous state. So basically, it is a transitory state between liquids and gases, which is widely explored in this particular terminology, which we know as aerosol. So aero plus zol, which gives us with this particular term, and it is the transition between the gaseous and liquid state. It is not necessary that the drug should always be solubilized in this particular formulation. It can be either in the soluble form or it can be suspended in the final formulation. So you can choose depending on the solubility of the drug, which ultimately needs to be included in the formulation. So, to understand aerosol, we need to understand this particular term, which we know as vapor pressure. So, imagine you have a beaker in which you have filled of the beaker with a particular liquid. Now, we all know that the liquid which is filled inside the container will be having various layers. Rather, I would say the molecules in that liquid is going to behave in different manner depending on the layer in which it is actually stored. We can say some of the molecules of the liquid will be having higher kinetic energy than the other molecules. So all those molecules which is showing higher kinetic energy will ultimately try to escape that liquid state and will bounce back to the gaseous state. There will be a continuous transition from the liquid state to gaseous state. The pressure which is exerted by such a system, which is made up of liquids which escapes evenly from the surface of the liquid, and the pressure which it ultimately exerts, it is known as vapor pressure. So let's have a look at the diagrammatic representation of the same. As you can see in the diagram, the container is having a blue colored liquid, and it is shown that the molecules which are present at the topmost layer of the liquid are trying to escape the liquid surface. It ultimately exerts the pressure which is shown by the gray colored lid region. This particular phenomena is known as vapor pressure. Now we have one more situation. If at all it happens that the molecules which try to escape the surface of such liquids, number of molecules which tries to escape the surface of such liquids is equal to number of molecules bouncing back from the vapor state to the liquid state, then such a situation is known as equilibrium vapor pressure. Let's have a look at the definition. It is shown or it is known by the phenomena when rate of condensation, that is bouncing back of vapor molecules to the liquid state, and rate of vaporization, that is transition of topmost layer of molecules having highest kinetic energy to the vapor state. If both the rates are equalized, then that is known as equilibrium vapor pressure. The saturated, the vapor which is above the liquid state ultimately becomes saturated. Okay, so that is why it is known as, some of the books also mention it as equilibrium saturated vapor pressure. and it is usually measured in millimeter mercury with the help of manometers. So now let's have a quick look at the basic parts of an aerosol. Now we know the terminology vapor pressure. Now it would be easier for us to understand the basic functioning of aerosol along with the parts of aerosol which we are going to discuss right now. Now there are basically four parts of aerosol which we need to consider at this stage, that is B Pump semester 3. First and the most important part, which we are also going to discuss in the presentation, is the propellant. It is the propellant which keeps that balance of pressure inside the container, and when the pressure is released, it also exerts the particular drug from the container to the patient at the required site. Okay, so that is the propellant which is doing all the functioning. It is also going to solubilize the drug. If at all the drug is soluble in that, it is also going to form a suspension out of it. If at all it is insoluble in the propellant. So propellant is the key role player in case of aerosol. Next is the container in which the entire formulation will be filled. It can be usually made up of any metal, but sometimes aerosol made up of glass as are also desirable as far as industry is concerned. Next is valve and actuator. Remember the format in which the particular formulation comes out of the aerosol. It is decided by the valve and actuator, whether that will be mist or it will be foam or it will be just droplets. It will be decided by ultimately valve and actuator. So the format in which the particular dosage form comes out of the aerosol is decided by valve and actuator. Last but not the least will be product concentrate. That is your drug along with the excipients. Excipients are usually required to stabilize the formulation for the required time of usage. So these four are the basic elements or ingredients which makes up the aerosol as a whole product. In this presentation, we are going to discuss about our key role player, and that is propellant. Usually, propellant is any material which is behaving as a liquid under pressurized situation, which is inside the container. And when the pressure is released with the help of valve and actuator, it is going to convert back to the gaseous state. So that is the most important requirement for choosing a proper propellant for our formulation. Before model propellants came to the market, it was initially based on chlorofluorocarbons and hydrofluorocarbons. But these kind of agents have a major disadvantage of depleting ozone layer. So now chlorofluorocarbons and hydrofluorocarbons are replaced by some other agents such as nitrogen and hydrogen for better convenience and proper usage. Please keep this thing clear in your mind. Now, how do we fill the entire product concentrate and propellants inside the aerosol? There are two different procedures which are actually utilized or followed in the industry. As you can see in the slide, either you can cool the propellant and drug at a low temperature and then fill it inside the container and then seal the valve, or you can add all the ingredients under pressurized condition, even at room temperature, and then seal the valve. It totally depends on the product concentrate, the propellant properties, which technique we are going to use. But both the techniques are widely utilized in the market. Now, what are the advantages of using aerosol as a product and why this particular formulation is so widely accepted in the market? There are some clear cut advantages. Say, for example, the first advantage, the antiseptic materials which is filled inside the aerosol can be easily sprayed and with minimum discomfort of the patient. Now, if we compare aerosol with a band-aid, then after the usage of band-aid, it is tedious or it can cause some amount of irritation on the patient's skin if we try to remove it after the usage. But aerosols are easily sprayable and they allow or provide minimum discomfort for the patients. That is why, to enhance that comfort, aerosols are utilized or preferred over band-aids. Aerosols are excellent delivery material for spraying of certain kind of anesthetic agents. It is widely used for spraying of local anesthetic agents before surgery. In certain body cavities where dosage forms cannot be applied easily, it is the aerosol based dosage form which is sprayed and provides desired pharmacological action. It is also utilized or it is also widely explored for certain biotechnology based products which are not easily delivered in conventional dosage. So because of these variety of uses, aerosols are widely explored. Thank you for your patient hearing. In this session, we covered what is vapor pressure and why it is required for being needed for aerosol based dosage form. We also discussed what are the basic parts of an aerosol and we discussed propellant in detail. There are certain properties of propellants which needs to be thought upon before choosing of a desired propellant for pharmacological use. We also talked about various techniques by which aerosol can actually be prepared in market. Then we also discussed why aerosol is chosen as a desired formulation over the conventional methods. Stay tuned for more such videos on our channel Pharma Ignite. Please like, share and subscribe. Thank you so much.